I was totally wrong. Well, sort of, but this changes everything once again. In this video, we're going to look at benchmarks that compare iterators, fully materializing collections, as well as paging. I'm going to be walking us through some of the benchmark code so that we can understand it a little bit better, and then going through all of the results in more detail to see what stands out. This isn't the first time that I've done a video on benchmarking some results like this, and to be honest, once again, I'm quite surprised by the results. And no, this isn't clickbait. I'm going to be explaining the things that I was expecting and totally wasn't expecting, and that's okay for me to be incorrect about what I was assuming. Just a quick reminder before we dive in to check out that pinned comment for a link to my free weekly software engineering newsletter. Alright, I'm going to start off the explanation by giving you a little bit of a disclaimer about some of the benchmarks that I'm looking at here. The reason that I have my benchmarks set up in this particular way, which I'll explain in more detail, is that I'm trying to get a feel for what things were looking like in production code bases that I was dealing with. This all stems from the fact that I was dealing with situations where people were fully materializing collections once upon a time. Then we moved heavily towards iterators, and then more recently I've taken a paging approach. So I wanted to be able to highlight some of the different ways that I saw people using fully materialized collections or iterators, and it doesn't necessarily mean that I think that they were using the right things, but part of this is to try showing that we want to be able to minimize some of the impact when people are using things incorrectly. So one of the particular cases we'll look at is counting records, and I was seeing that people were basically querying entire data sets to be able to count records. We know that this isn't the right thing to do. We should write dedicated queries for this, if that's what you're interested in, but I wanted to be able to show the impact of doing this sort of wrong way if you're using fully materialized collections, iterators, paging, and other options that we have. So some of the things that the benchmarks covered that I was interested in include things like fully materializing very large data sets into memory. As I mentioned, being able to count results, and that's either using LINQ or again, fully materialized data sets. And in particular, when we talk about LINQ, doing things like calling any on a result set when really we don't need a full result set or even the type of query that we were using. We just wanted to check if there was anything, and that happened to be the data that we had access to. And before going over to Visual Studio, I just wanted to give you a high-level view of what the code is going to look like so that when I scan through it, you have some of these things in mind already. We're going to be looking at result sets of different sizes because I think that's important when we're benchmarking things to see if the performance and the memory usage starts to change over time as we are doing different sizes. So we're going to be looking at result sets that are 1,000 items, 100,000 items, and 10 million items. Some of the things that we'll look at in particular are using the any LINQ method, being able to do different types of counting when we're not directly calling a query that is strictly responsible for counting, and then fully materializing entire result sets. In terms of some of the implementations we're going to look at, I am going to be using Entity Framework Core, and that's going to be backed by an in-memory SQLite database. The SQLite database being in memory was just for simplicity. I didn't want to go set up an entire MySQL database to go connect out to, so just something simple like an in-memory SQLite option seemed to fit. And I'm also going to be comparing doing raw SQL queries with Entity Framework Core. And that's because I still to this day do a lot of manual SQL queries, and I'm not really using Entity Framework or Dapper or anything like that. So part of that was for me to try to get some exposure to it, make sure that I'm understanding some of the nuances there, and opening up my own eyes to what I could be doing. And I know you want to see some results, so let's go check out some code super quick, and then we're going to go do the analysis. All right, so I'm going to be using BenchmarkDotNet here. This is my go-to, and I think it's the same thing for a lot of people working in CSharp that want to get some benchmarks. So you can see right at the top, this is just a really lightweight setup to be able to get BenchmarkDotNet to run. I'm using the benchmark switcher, and then that way I'm able to go run the benchmarks that I'm interested in. From here, we just have a simple record that we're going to be dealing with. It just has an ID and a username, so very, very lightweight. And the sample DB context just has users as the data set that we're interested in. Now, before I get into the individual benchmarks, what I did was created this benchmark fixture, which is just a reusable class to set up some data and then access the data in the different ways that we're interested in. So when I go to do the setup, I'm creating a SQLite connection. We're using this because I want to also have access to the connection to do raw SQL queries. And down here, you can see that I'm setting up Entity Framework by getting the context created and leveraging that same SQLite connection that we just created above. And then in order to have these test scenarios work for the benchmarks, I'm seeding the database with a number of entries. And I mentioned that this is going to range from 1,000 up to 10 million, depending on the scenario. So we save those out. And this part here is important for me. It's not included in the benchmarking time, but I wanted to guarantee that I had the right number of results in the data set. And yes, this seems kind of silly, but I just wanted to pause for a moment because I wanted to send this type of information out to my newsletter audience about a week ago. And the issue was that I was creating these benchmarks, and when I got the results, they just weren't right. And I don't mean not right in that they were disproving what I had to say. I mean, they were doing that, but at the same time, the actual results that were coming out didn't make any sense. When I was materializing a collection of 10 million items, it was saying that it wasn't taking any memory. That's not right. It should take some amount of memory to store any type of results. So for me, this was an issue where I was clearly doing something wrong with my benchmark setup. I remember talking to my wife about this and being frustrated and saying, I don't know what I'm going to do. And she said, well, why don't you tell them the truth about the results? And I said, well, I'm trying to, but the results just aren't right. I need to figure out what I'm doing wrong. So this was just a quick sanity check, and I wanted to share with you that I was getting frustrated with collecting these benchmark results, but ultimately, I think we figured things out. This is just a quick sanity check left in place. And that's really going to be the end of seeding our data and making sure that we're good to go for our benchmarks. So the rest of the methods that are in this class are just the reusable calls that we can do to access the data. So in order to get a fully materialized result set from Entity Framework, I'm just calling the users property and then calling toList, and that's going to give us the entire set. The next part is going to be using an iterator approach. So the only real difference between these two, you can see that I'm not doing toList on it, and I'm just returning up the IEnumerable. And I'm going to pause again because this is really interesting. It's kind of like rubber ducking when I'm going to make this video, but I just clued into something here, and this is a really important part about iterators and IEnumerables and the whole reason that I started making this video series. My goal here, if you looked at the name of the method, was that it was the iterator approach for Entity Framework Core. I'm returning an IEnumerable. I don't anywhere in that method have yield return. I have no idea if this is truly an iterator, and that's a huge missed opportunity for me to ensure that I'm doing the right thing here. So I need to go back after all of this and go address some things that are going to come out of this video. I'm hoping that if you have some comments about how some of this stuff is set up, then I can go address those as well. But the point here is that this is supposed to be an iterator. I, in fact, cannot guarantee that because I don't know what it's doing under the hood for Entity Framework Core. So this one might not actually be an iterator. So we might see some interesting results for this one that don't line up with iterator usage. Below we have getting users that are paged through Entity Framework Core. So you can see that I'm using skip and take. When using Entity Framework, this should get pushed out into the database. So skip and take otherwise would be working on a result set in memory. So if you are doing this kind of thing and it's not translating your link to SQL, what would happen is you would get the full data set, and then in memory, you would skip over the amount specified by offset, and then you would go do take on that result set in memory. But because this should be doing link to SQL, this offset and page size should become part of the query and done at the database level. Next, we get into some of the raw SQL queries. So you can see that I'm just doing get star from users and then doing paging and an offset. These values get passed in here as parameters. And then what I'm doing is putting this information into a list. And you can see that the return type is an IRead-only list because in my previous videos, I mentioned that I like using IRead-only list as a return type. And then this variation right below is very similar, but because this return type is now a list, everything else in here is the same, but this return type as a list is because there's supposed to be some optimizations for doing for each loops on lists and arrays. And if I scroll back up, when we're dealing with an IRead-only list, I cannot guarantee that the compiler knows that it's backed by a list or an array. So we're hoping to see if there's some difference here with using a list in terms of performance. This next one here is also very similar. You can see that the paging is taken out of the SQL query, and then instead of putting the information into a list, I am now using an iterator. And this one is for real an iterator because we have yield return as well as IEnumerable. These are the two ingredients that we need for an iterator. And last but not least is getting all of the result sets through raw SQL queries and putting them into a list. So you can see here that I have select star from users, no paging, and then I'm putting everything into the list. So it's very similar to one of the ones that we saw earlier without the paging involved at all. And next I'm going to go through some of the benchmarks, but instead of showing you every single one of these, because there's a lot and they follow the same pattern, I'm just going to show you one of the examples of these to save some time. So we're going to go through the any benchmark example, and you can see that I'm doing the data sizes that I mentioned earlier. We call this fixture to get set up on the global setup, which runs before the set of all benchmarks. So that means that as this parameter changes, we'll go run this another time. Next, we get into the individual benchmark runs, and because I pulled that code out to be reusable, we've already looked at most of what it's doing. So that's why I said I don't want to waste all of your time going through all of the examples of these. But we can see that when we're doing any for a fully materialized entity framework core, all that I'm doing is calling that method here, and I'm just doing count equals not zero. So this is a slight optimization, because if we're calling any on a list using link, it should, in theory, be able to short circuit for us behind the scenes because it knows it's a list, and that way it has the count property available to us. So any and the link method does do this behind the scenes. I'm just taking a shortcut. Same thing with this fully materialized raw SQL one, just doing count, so it's not the link method, but that's because we have access to this count property. As soon as we get into the iterator situations, we can see that for both of these, I'm doing raw SQL Entity Framework Core, but I'm just calling any on here, and that's because we don't have a count accessible to us. Keep in mind that this is supposed to be replicating what some people would be doing in production code bases that I saw. Next, we're going to look at a paging approach. So if we just wanted to check if there was anything available, we could go pull back one record and ask if there's anything there. Again, you'd probably want to go write a dedicated query for this, or you don't pull back any records, just a Boolean if the count is greater than 0. We'll do the same thing with a page raw SQL query instead of Entity Framework Core. Again, these are different because the paging approach with raw SQL has an IRead-only list, and the Entity Framework Core one is still just using an IEnumerable. And finally, the last one here is only different from the one above it because we are dealing with a list versus an IRead-only list. You can't see that from how this code is written here, but when we looked at the implementations, that was the difference. And I won't go through all of them in detail, but the count benchmarks are almost the exact same. You can see that they're just set up in a very similar way, but they're doing count or count with the link method instead. And as I mentioned, I have the fully materialized benchmarks as well, so we're going to look at the results of those. So that's all there. We already looked at the code behind that it's going to be calling. It's just that the benchmark code is sort of a one-liner that calls into that. And now what you're probably interested in is the results of those benchmarks. So let me pull those up. They're going to be in Paint because I had to go adjust the screen a little bit to fit it all. So I didn't go doctor the results. They're interesting. I didn't have to do any doctoring to make them interesting, but I needed to fit them on the screen properly. So I'm going to have them in Paint. That's why it's a little bit weird. Let's go check it out. All right, there are a ton of numbers on screen, but I have them highlighted for us already to call out the ones that are outstanding. The first data set in this magenta color up at the top here is for 1,000 records. It looks like using the iterator approach with raw SQL is not only the fastest, but has the smallest memory footprint that we can see over here. And the worst offender is going to be materializing the full thing with raw SQL, so that's the slowest. And if we check out the fully materialized Entity Framework Core, that has the biggest memory footprint. Otherwise, the fully materialized raw SQL one is also pretty terrible in comparison. And I think that that checks out. This is kind of what I would expect because calling any with an iterator is nice and lightweight. We don't have to go materialize the entire data set. And that's why I expect the allocated memory to be quite low and the runtime to be pretty quick as well, because we don't have to get a lot of data. Interestingly though, if we look at the Entity Framework implementations, the memory footprint's a little bit bigger comparatively. So this one here is over 5 kilobytes. This one here for Entity Framework is almost 3,000 kilobytes. And then of course we saw this heavy hitter here. So comparatively, they are higher than doing the other implementations. We can see that when we're doing page with the raw SQL query, the one that was returning an IRead-only list happens to be the fastest, although it's extremely comparable to returning it as a list. This is a little bit weird in my opinion because I would have expected that the second one would have been faster, but they're very, very similar, so this could just be related to error. These two approaches also have the smallest memory footprint with just over 1,000 bytes. Now the worst offender is counting with a raw SQL query, so that's right here, and we can see that the worst offender for a memory footprint is again a fully materialized Entity Framework core set. Just a quick look at the runtimes for all of these though, they're all pretty bad when you're doing a fully materialized collection or an iterator. And the reason that an iterator is also pretty crappy for performance here is because when we have to call the count link method on an iterator, we have to go resolve that entire data set in order to be able to count. So again, nothing too surprising here for me. And now when we look at the fully materialized data sets, we can see that the fastest implementation is a fully materialized Entity Framework core dataset. However, if we're looking at the worst case, which is the fully materialized raw SQL one, we can see that they're all roughly in the same range. This is not too outrageous when we start comparing them. They're all pretty close. Now, the paged raw SQL implementation is also very, very similar to the fully materialized Entity Framework core, but all in all, I don't see a huge swing in the different performance here. If we start looking at the memory footprint, however, we can see that the Entity Framework core implementations of things are a lot heavier. So they all are going to resolve the full materialized dataset. That's why these are higher in memory. But it's interesting that the Entity Framework ones are across the board higher memory usage than the others. But the result sets are going to become a little bit more interesting as we press forward. So far what we've seen is that Entity Framework core basically across the board has a higher memory footprint. And something else, and this one's not very surprising, is that the slowest implementations of things seem to be when we have to fully materialize a data set, especially even when we shouldn't have to. And the other thing, and this isn't really surprising, is that the slowest implementations of things happen to be when we're fully materializing a data set. And that's either because the implementation we're asking for explicitly is materializing a full data set, or because we're using link to do something like counting over an iterator, and we shouldn't have had to go fully materialize a data set, but we are anyway. So these are really, in my opinion, sort of just misuses of link or the SQL queries that we're running. That one's not totally shocking. Let's go check out the other benchmarks. I'll start to gloss over the things that are largely the same, so when we're talking about the performance of fully materialized stuff or the memory footprint of Entity Framework, that's not going to be totally interesting because that's going to be a common pattern we start to see. What starts to become more interesting is that the performance of Entity Framework starts to pull ahead in some cases, so I want to scroll through that and look for some of those examples. We can see that here for the any and count implementations in this section that the difference between what we were seeing before and what we're seeing now is very, very similar, right? The performance of any iterator compared to fully materializing is of course going to pull ahead. And when we start to look at the count, it's the same type of thing. However, when we start to get these fully materialized data sets, I feel like we're starting to see a little bit of a difference in terms of the numbers. And this might just be because I'm noticing them more when they're blown up to a higher magnitude, but let's have a look. The fully materialized iterator using raw SQL is what I would expect. This is one of the reasons why originally I tried getting people to move away from using fully materialized data sets in the first place because they were doing things like fully materializing things they shouldn't, and then trying to do operations on tons of records in memory. Again, the right thing would have been to change the query to get what they need. However, this is just something that I observed in production. But we can see that when we're looking at Entity Framework here, it starts to pull ahead consistently. So we can see that the fastest implementation here is just under 28,000 microseconds. But if we go up to the other Entity Framework records, we see 28,000 and 28,000. These are consistently faster than the other implementations we have here, including when I'm doing raw SQL. So I thought that was a really interesting thing to point out, that they're notably faster here. And again, if we look at the memory footprint, consistently the Entity Framework stuff is a lot worse for the memory footprint. If we scroll down a little bit lower to the 10 million record size, I think we start to see the same type of pattern showing up, with Entity Framework really pulling ahead. Again, any and count, not totally interesting. It's very similar to what we saw before, but these fully materialized data sets just become really interesting in terms of the performance of Entity Framework. Again, we can see that if we're looking at the slowest, the fully materialized raw SQL one is by far the worst. And it's a similar thing if we're looking at the iterator for raw SQL, because once we get that iterator and then try to pull it all into memory, it's going to be slow as well. So these two things, pretty bad. The paging implementation for these two things is also kind of bad because it's effectively doing the same type of thing. It's just changing the query marginally under the hood with the paging parameters. But the paging parameters are the entire data set anyway. So what's really interesting to me is that Entity Framework again pulls ahead. We can see right here and right above in the green is the fastest, and again up here at the top for the fully materialized data set using Entity Framework, it's faster than every single implementation that's not using Entity Framework. So very cool. And again, if we look at the memory footprint, all of the Entity Framework stuff is significantly worse than the others. So here and here as well, and the red is of course the worst, which is Entity Framework with the fully materialized data set. So this is really cool to me because I wasn't expecting to have any interesting results from Entity Framework. I just included them because, like I said in the beginning of this video, I don't really use Entity Framework. I'm writing my own SQL queries, and I figured I might as well throw it into the mix to learn about something. One of the things that I set out to prove in this video, because I was pretty confident about it, is that the performance of iterators was going to be slower than a fully materialized collection. Of course, if we're doing something like calling any when we shouldn't have to fully materialize a data set, an iterator's going to be faster. I wanted that to show through. But what I wasn't expecting is that Entity Framework, even with an iterator, was going to outpace a fully materialized collection doing a raw SQL query. Totally unexpected to me. But the other thing that's interesting is that the memory footprint of doing so is a lot greater with Entity Framework. Now, I need to admit, and I kind of did at the beginning, that because I don't use Entity Framework, there's going to be stuff about this that I'm not optimizing properly or assumptions that I'm making that if I get your feedback, you might be able to say, well, you set up this benchmark wrong and it's not really a fair comparison. So please feel free to share that in the comments, and I'm happy to go back and redo some of these and share the results. And at this point, you're probably saying, well, Nick, you missed the most important benchmark. You set out to go look at paging. You don't have any paging here. You're getting the fully materialized data set as the only page. That's a really big page. But don't worry, I did in fact go get these benchmarks. I mentioned earlier that when I was explaining to my wife that all this stuff was busted and I couldn't send out my newsletter as a result, when I finally got this to work and get real data coming back that wasn't totally clobbered, I didn't include the paging and had to go back after I ran all the benchmarks to go add it. I think I was too eager to see it working, but I do have those results and we'll check them out next. And now with these results, I was totally wrong. Well, sort of, but this changes everything once again. All right, so this is a paging benchmark that's pulling back 100 records for the different full data sets that we have. So this is a smaller set because I'm only looking at methods that are going to make sense for pulling back pages of things. Looking at the 1000 item data set, pulling back 100 pages, the fastest implementation is a paging approach with raw SQL. It's very comparable to the others, so this group right here is all very similar. And then the worst is, of course, doing a fully materialized raw SQL dataset. It's also comparable to getting the Entity Framework result set fully materialized. If we look at the memory usage, the iterator approach for raw SQL happened to have the lowest footprint, and then the others for paging with an IRead-only list and a list are almost the exact same for memory footprint, so very, very small. And not surprisingly, using Entity Framework is orders of magnitude more than what the others are. Overall, though, the performance very, very comparable when we're dealing with 1,000 records. When we start to get into 10,000 records, we can see that the iterator is pulling ahead for the performance using Entity Framework Core. And the page results are almost the same performance, but Entity Framework with an iterator did manage to pull ahead. These numbers are very, very similar, but it's kind of disproving my theory that having a paged implementation was going to be faster. The memory footprint that we're seeing on the right here is almost the exact same that we saw above, so nothing really surprising on the memory side. And in fact, for the next section, it's going to be the same thing, so we'll skip over that. But the most surprising thing that I saw in this data set was looking at these numbers here when we're pulling back, dealing with a very large set of data in the database, and only pulling back 100 records. We can see that the fastest implementation had nothing to do with my new paging approach that I was taking in my code. In fact, it's just using an iterator with raw SQL. This is literally what I just moved away from in my code base to try doing these two things down here. The reality is that these numbers are very, very similar, so I'm not too upset that I moved away. I'm just totally shocked that I thought the iterator was going to be much slower for pulling these pieces of data back. Now, of course, I'm not changing the size of the page, and having only 100 items come back, in my opinion, makes it even more surprising that the iterator is performing even better. And that's because there's overhead for setting up the iterator in the first place. So personally, I would expect for a small number of items, like 100, that the iterator should have more overhead for performance. But what we're seeing here is not only does it not have more overhead, it's going faster. Okay, so what have I learned from doing all of this? The first, and I think this is the biggest takeaway for you, is that doing performance analysis of things in isolation does not necessarily translate to the same performance gains in practice. When the queries are set up comparatively, iterators should be slower than putting stuff into a list or an array. But there's clearly some nuances here in how the code is set up. The other takeaway for me is that doing a fully materialized collection as the only way to get data sucks. And this one's not a shock to me. This is the motivation behind all of this that I've been talking about. If that's the only way that you're accessing data, I think you really need to go back and revisit your data access patterns, because if you're always pulling back all of the data and then trying to work on it in memory, there's probably some more optimal ways that you can do that. The next takeaway for me is Entity Framework. It looks like across the board it's significantly worse with memory, but it happened to be pulling ahead a lot in terms of performance. Now, one of the things that I learned as I was making this video, and I included it earlier, was that I had this moment where I said maybe the iterator approach that I put in for Entity Framework isn't truly an iterator. I can't tell because it's just an IEnumerable return type, and I can't tell if it's yield returning anything under the hood. I would have expected that it is, but maybe it's not. And if that's the case, I need to go back and force this to be a for loop with a yield return so that it forces it to be an iterator. Regardless though, Entity Framework was using up more memory, but it happened to be a lot faster in situations where I just wasn't expecting it to be. So I have a lot still to learn with Entity Framework Core, and that's going to bring me to my last point here about some of the tech choices that I made. So yeah, this was all with SQLite. I'm not even using SQLite in my production system, so SQLite was just a way for me to set this stuff up, make it nice, quick, and easy for the benchmarks. But if we're talking back to my first point about doing things in practice, I should be going to benchmark my real application to see how I can tune it. This was more of a generalized approach, so SQLite maybe has some different performance characteristics from MySQL, but I was trying to focus more on the implementation of what we're doing once we're in memory versus the querying part itself. So that is just another difference that I want to call out, and it's not necessarily an apples to apples comparison with what I have in production. So I do have a couple of more benchmarks to go rerun to see if anything else stands out with the Entity Framework stuff, and I need to be using Entity Framework more in my project. So the next vertical slice project that I put together, I'm going to be trying to use Entity Framework, and if you want to see more about vertical slice architectures, you can watch this video next. Thanks, and I'll see you next time.